So here we have a condition given to us. That means the sum of the three angles of a triangle is pi radians. We need to show that sine of A added to sine of B added to sine of C, that equals to 4 times the product of cosine of A over 2, cosine of the half angle B over 2, and cosine of the half angle C over 2. Okay, let us begin. Now here, this is an conditional trig identity. To understand conditional trig identity, let's take the help of a normal identity given by sine squared theta added to cosine squared theta equals to 1. Now, this is referred to as an identity because it's true for any values of theta that we choose here. For any values, or we can say for all values of theta, this is always going to be true. That's why it is an identity. However, for this particular problem, this is going to be true for some specific values of A, B, and C, such that their sum equals pi radians. That's why such an identity is going to be referred to as a conditional trig identity. Okay, now what we'll do, we'll try to prove this by starting from the left hand side. So on the left hand side, we have sine of the angle A added to sine of the angle B plus sine of the angle C. Okay, so let's try to find out. So first, we will begin by taking the sum of the first and the second term. So what we'll do, we're going to use the standard formula. So when we take the sum of sine A and sine B, then we are going to get 2 times sine of the angle A plus B over 2 multiplied to cosine of the angle A minus B divided by 2 added to. Now here we have sine C. There's a standard half angle formula. So whenever we have sine theta, that's given by 2 times sine half of that angle theta multiplied to cosine of half of that angle theta. So we cosine theta over 2. So in our case, our angle is C. Now this is going to give us 2 times sine of angle C over 2 multiplied to cosine of the angle C over 2. Okay, now we have A plus B over 2. So here we are going to work with this. So we have sine of the angle A plus B over 2. Now, if we use this condition that A plus B plus C equals to pi, we can rewrite the numerator A plus B as sine of pi minus C over 2. But there's an advantage of writing in this particular fashion. Now what we have sine of pi over 2 minus C over 2. Now this is a standard formula. Sine of pi over 2 minus some angle theta, that gives us cosine of that angle theta. So in our case, as theta is represented by C over 2, we should get cosine of C over 2. So sine of pi over 2 minus C over 2 is cosine of C over 2, or in other words, we can say cosine of A plus B divided by 2. This is going to be the same as cosine of C over 2. We're going to replace this with cosine C over 2. That is going to now give us 2 times cosine of the angle C over 2 multiplied to cosine of the angle A minus B divided by 2 added to 2 times sine of the angle C over 2 multiplied to cosine of the angle C over 2. Okay, now let's take 2 times cosine of the angle C over 2 as the common factor. So this is now going to get multiplied to cosine of the angle A minus B over 2 added to sine of the angle C over 2. Okay, so now what we'll do, we're going to furthermore simplify sine of C over 2. We're going to use the same idea that we use for finding out sine of A plus B over 2. Now, so let's say sine of C over 2. This can be also expressed as sine of the angle pi minus A plus B whole divided by 2, meaning we have sine of pi over 2 minus A plus B over 2. So we are going to get cosine of the angle A plus B over 2. So let's use this. We're going to get 2 times cosine of C over 2 multiplied to cosine of A minus B over 2 added to cosine of angle A plus B over 2. Okay, so here we have to sum up two cosine functions. So this is a standard identity. We have cosine of C added to cosine of D. So that is going to be given by 2 times cosine of the angle C plus D over 2 multiplied to cosine of the angle C minus D over 2. So in our case, what we'll do, we're going to consider C to be equivalent to A plus B over 2 and D to be equivalent to A minus B over 2. So let's do one thing. Let's add C and D. So if we add C and D, so that's going to give us A. And if we do C minus B, D, that's going to give us B. So let's further simplify now. We are going to get 2 times cosine of C over 2 multiplied to, so when we use this identity, we're going to get 2 times cosine of A over 2 multiplied to, we need cosine of A minus B over 2, or in other words, we need C minus D over 2. That's going to give us B over 2. Okay, so finally, we are getting this equals 4 times cosine of angle A over 2 multiplied to cosine of angle B over 2 times cosine of angle C over 2, which is the expression on the right hand side. So we can say thus, we can say that sine of angle A added to sine of angle B plus sine of angle C. So this is going to be equals to 4 times cosine of angle A over 2 times cosine of angle B over 2 multiplied to cosine of angle C over 2. And this is going to be true for A plus B plus C equals to pi radians. Hence proved.